This question says, determine the gravity on a planet that when an object with a mass of 5 kilograms is 10 meters above the surface, the resulting potential is 128 joules. So let's go ahead and draw it just to see what's going on. We have an object that is 10 meters above the surface of the Earth, or excuse me, the surface of the planet. We can't assume that it's Earth anymore because it says determine the gravity on a planet. So we know we're no longer talking about Earth. We know that the object is 5 kilograms and it's 10 meters above the surface of the Earth. So we can say we are trying to solve for G. Now a lot of people have issues with that because they say, well, G is always 9.8. Remember, G is 9.8 on the Earth and on the Earth only. So we have GPE equals MGH. We have the mass as 5 kilograms. We have the height that's 10 meters. And we have the potential energy as 128 joules. So what we do is we say GPE equals MGH, and what we do is we divide both sides in order to solve for G by MH. When we divide both sides by MH, it cancels out, leaves us the G term, and so we have G is equal to GPE divided by MH. In our case, that would be 128 divided by 5 and 10. Remember, when we're putting this in the calculator, we want to make sure we do this first. And when we do that, we get 128 divided by 50, and you get 2.56. Now this is G, so we should be measuring this as meters per second squared. Now we do want to make sure that that value is actually correct, so we look at our units. We say, okay, the joule, remember, is a kilogram meters squared per second squared. And we divided it by mass, which is kilograms, and height, which is meters. So, kilograms cancels out, meters cancels with the squared term, and what I'm left with is meters per second squared, which is what I want it to be.